Again, in this session, we will discuss in detail the various parameters related with the selection of transducer. There are three characteristics which are input characteristics, transfer characteristics, and output characteristics. So we know for a transducer, it will convert one form of energy into another form. So because of that reason, the input as well as output are equally important. And the transfer characteristic refers to the type of influence the system or the transducer make on the signal under consideration. So we will see each of this in detail in the upcoming slides. Input characteristics. This is the most important among the three, and which will comprise this comprises of three elements. One is type of input, then operating range, loading effect. We know the transducer selection will vary based on the nature of input signal. If we want to measure a sound signal or if we want to measure a pressure or a temperature of an area, the selection of transducer will be different. So the nature of input is a key parameter. Then the operating range. For a particular type of input, based on the range of values to be measured, the selection of transducer will vary. For example, for sound signals itself, when it comes to a larger variations of sound signal, we may not be able to use a condenser microphone which works based on a capacitive transducer. Rather, we will be going for a diaphragm based transducer. So the choice was basically based on the range of values of the input signal. Then comes loading effect. Loading effect refers to the influence of the present stage on the succeeding stages of the instrumentation. If the present system highly influences the succeeding stage, the transducer selection will be significantly varied. Then coming down to the next characteristics, which is transfer characteristics. It refers to the influence of transducer on the signal under consideration. First factor is transfer function. We know the transfer function refers to the input-output relation. For a particular variation in the input, how much variation will it bring there in the output? And the second parameter under transfer characteristics is error and hysteresis. We have discussed about it in the previous module in detail. We know the error refers to the variation of measured value to the true value, and hysteresis refers to the variation in the measured value when it is measured from the bottom and increasing the quantity, reference quantity, and when it is being measured in the top down fashion, means choosing a larger value then decrementing and measuring the particular quantity. So there will be error, change in value on the two type of measurement, then that refers to the hysteresis. Then third factor is accuracy and precision. Accuracy and precision, precision stands for the repeatability, extent of repeatability. If we repeatedly measure the same quantity, if there are changes, then that is refers to lack of precision. And finally comes response of transducer to the environmental influences. If the instrument or the transducer is used in a highly changing environment, for example, in an environment having a larger variation in temperature or maybe a larger variation in pressure, then the choice of transducer will be different. Then the last characteristics is output characteristics. Again, it consists of three parameters. One is type of input, type of output, output impedance, and useful range. So type of output. So the desired output, type of output we require. Mostly it will be electrical output, electrical signals. And for inverse transducer, we know it actually converts the electrical signal to some physical quantities. So based on that, the output, the choice of transducer will change. The second among output characteristics is output impedance. Output impedance refers to the resistance, output resistance of transducer. It will be different for different transducer. Maybe for piezoelectric transducer it will take a particular value. For capacitive transducer it will take a totally different value, and based on the succeeding stage in the instrumentation, it comes to a critical parameter. Then the last one is useful range. The useful range of output. Sometimes the output will be connected to a loudspeaker, or sometimes it may be connected to an amplifier in the case of microphone. So based on these two applications, based on these two succeeding stages, the range of output will be different. So that is all about output characteristics.